Hi everyone. So this video is about the third method we're going to learn this year for solving simultaneous equations, and it is known as the method of elimination. So let's think about what elimination means. Elimination means to get rid of something. So we are getting rid of something in this process. We are getting rid of one of the variables because as it stands, we can't solve an equation that has more than one variable in it. So we need to get rid of one of the variables. And all the methods that we've learned so far have all done that in a slightly different way. So this method requires that one of your variables have the same coefficient, the same number in front, and an opposite sign. And then what we're going to do after we achieve that goal is add together the equations. Okay, so let's start. We're going to go through three different examples, and I kind of label them as three different levels of difficulty. Difficulty level 1, I don't have to change anything. Difficulty level 2, I have to change one of the equations. Difficulty level 3, I have to change both of the equations. And we'll get into what that means as we go through the examples. So as we look at our first example, we see that we already have one of the variables that has the same coefficient in front of it and an opposite sign. The y value in our first equation has a positive 2 as its coefficient, and the y in our second equation has a negative 2 in front of it. So this is difficulty level 1 because I already have in the equations I am given what I need to be able to do this method, which is same number, opposite symbol in front of one of my variables. Also take notice that both of these equations, or I should say neither of these equations, are written in the form y equals. Most commonly, you will use elimination when both your x and y are on the same side of the equal sign. If you had one or both of your equations written as y equals, you would more than likely use either equating values of y or substitution as your method for solution. So x and y on the same side, and again, we already have what we need, which is one of the variables, same coefficient but opposite sign. Once we have that, then what we're going to do is go ahead and stack these equations on top of each other. So x's line up with x's, y's add up with y's, constant terms add up with constant terms. And we're going to add these up. So we're going to add through by the columns. So we've got 3x plus x, that gives us 4x. And then note what happens when I have positive 2y plus negative 2y. That gives me 0y. So that entire variable has been eliminated. That's the point of the process. So we leave that because we don't need to write anything down there. And then we have equals 8 when we add up the 5 and 3. So now what you see we have is we have this little tiny linear equation of 4x equals 8. So we're going to go ahead and solve that by dividing both sides by 4 and getting ourselves a final answer of x equals 2. So now we're halfway there. We have solved what x is, and now we need to figure out what y is. There is not an obvious choice here for which of the equations we're going to use to solve for y. Neither of them are written as y equals, which is super handy. Set up to solve for y, that's exactly what we want to see. We don't have that. So it becomes personal choice, which one you think looks easier to solve if I replace the x with the value that I just figured out, which in this case is 2. You might go with the top equation because everything is positive. You might go with the bottom equation because x doesn't have a coefficient. Done properly, you're going to get the same answer no matter which equation you choose. So it's just personal preference. Pick the one that you think looks the easiest. For me, my preference is to avoid negatives if I can. So for me, I would more than likely choose the top equation to solve for y. I would say just as many people would choose the second equation. It's totally fine. You're going to get the same answer done properly. So I'm going to replace x with what I just figured out x to be, which in this case is 2. And then I'm going to solve for y. So I'm going to do that multiplication, which gives me 6 plus 2y equals 5. Now I need to get rid of everything that's around my y. So I'm going to subtract 6 from both sides, leaving me 2x equals negative 1. Then I'm going to divide both sides by 2, and I get a final answer of y equals negative 1/2. So x is 2, y is negative 1/2. So that's difficulty level 1. I didn't have to alter the given equations in any way because what I needed to have set up was already set up. So let's go to difficulty level 2. So you'll notice with these two equations that we don't have one of the variables, either x or y, with the same coefficient and an opposite symbol. So we've got one of the variables with opposite symbols, but we don't have the same coefficient. So that means I cannot just go ahead, stack them, and add them because nothing is going to get eliminated. So what I need to do is I need to alter one or both of the equations. In difficulty level 2, you can get to the point of having that same coefficient with opposite symbol by altering one. So for me, for this one, and again, there are multiple paths you can take here, so I'm just showing you one of them. I am going to multiply this second equation by 2. And what I mean by that is I'm going to multiply every single term here by 2. If I do that, that is going to result in y having a coefficient of negative 2, which is what I'm after. So I'm going to leave my first equation alone, and then I am going to multiply my entire second equation by 2. So resulting in 10x minus 2y equals 4. And then again, first equation not changing, staying exactly the same. Oh, I forgot my y. So now what you'll notice is that I have one variable, y in this case, where one of the equations has a positive 2, one of the equations has a negative 2 as a coefficient for y. That's what I need. I need one of the variables with the same coefficient but an opposite sign. Once I have that, I go ahead and stack them and add them together. So this gives me 13x. Y has now been eliminated, gone entirely, equals, and I have negative 2 plus 4, which gives me 2. Oh, I just realized I did not write that 27. I just wrote the 2. Goodness. Okay, so then that's going to change this. When I multiply 27 by 2, that's going to change that to equals 54. That makes more sense. Wondered why this wasn't working out. Okay, so then that becomes 52. There we go. Much better. Okay, so continuing on, now we've got this little equation where we're going to divide both sides by 13. So then we get final answer of x equals 4. All right, halfway there. So we figured out x. Now we need to figure out y. So we're going to go back and use one of our original equations, again, whichever one looks the easiest to you, to solve for y. I am going to choose the first one. Again, I like to avoid negatives if I can. Personal preference. So I'm going to use 3x plus 2y equals negative 2. So I replace x with what I just figured out x to be, which is 4, plus 2y equals negative 2. So now I have 12 plus 2y equals negative 2. I'm going to subtract 12 from both sides. 2y equals negative 14. Then I'm going to divide both sides by 2, and I get y equals negative 7. So final answer, and be sure you make this clear because your final answer could end up in two very different places. Final answer, x equals 4, y equals -7. Okay, so that's difficulty level 2. I had to adjust one of the equations by multiplying it by a factor, in this case a factor of 2, to set up a situation where I had the same coefficient but opposite symbols in front of one of my variables. Now we're going to look at what I call difficulty level 3, where you have to adjust both of the equations. So in this case, I look at these equations and I look and say, okay, well, I can't multiply any 5 by anything, no whole number, to get an answer of 7. And I can't multiply 2 by anything to get an answer of 3. So it's not going to be like the same as level 2, where I could just multiply something, one of the equations, by one factor. This particular method opens up the most options for students, because some people will say, okay, I want to go ahead and I want to target x. So I'm going to multiply, top equation by -7, bottom equation by +5. Someone else is going to come along and say, no, I want to eliminate y, so I'm going to make those two, the variable of y, have the same coefficient with an opposite symbol. Then one person's going to say, I'm going to make the top one negative. Someone else is going to say, I'm going to make the bottom one negative. So there's a lot of choices here and options for you. So I'm going to walk through one method. You may get to this question on your own and say, I'm going to walk through in a different way. I'm going to make the top one negative, but she made the bottom one. You get what I'm saying. So I'm looking at these two equations, and I see 5x plus 3y equals 12. 7x plus 2y equals 19. And for me, I look and say, I'm going to target y, because the numbers will end up being smaller if I look at 2 and 3, and essentially I'm after the lowest common multiple. I'm imagining that I'm doing a fraction question where one of my denominators is 3 and one of my denominators is 2, and I want to get them to be the same denominator. So lowest common multiple is going to make your numbers the smallest. But again, same as when you're finding lowest common denominators, doesn't have to be the lowest common multiple. It just needs to be a multiple. So for this one, I'm going to multiply the top equation by 2 and the bottom equation by -3. My target is get the same number in front of y. So if I multiply this first equation by 2, that's going to make that coefficient 6. If I multiply my bottom equation by -3, that's going to give me -6. And that's what I want. I want the same coefficient, one positive, one negative. All right, so let's go through and do all of these multiplications. So that's going to give me 10x plus 6y equals 24. And then if I multiply every single term in the second equation by -3, that gives me -21x minus 6y. Look at that. I've got my coefficients of y set up properly. Equals -57. So then once I've established one of the variables with the same coefficient but opposite symbol, stack them, add them. So adding up my x's, I get -11x. Adding up my y's, that got eliminated, equals 24 plus -57 gives me -33. So then I'm going to go ahead and solve -11x equals -33 by dividing both sides by -11, giving me a final answer of x equals 3. So again, halfway there. I have solved x. Now I just need to solve for y. So I go back and choose one of my original equations, whichever one looks the easiest to you, and solve for y by substituting x. So for me, I'm going to choose the top equation on this one. So I've got 5x plus 3y equals 12. I replace x with what I just figured out x to be, which is 3, plus 3y equals 12, and solve. So 15 plus 3y equals 12. Subtract 15 on both sides, and I get 3y equals -3. Divide both sides by 3. X equals -1. Oh, sorry, not x. Y equals -1. So now I have the two pieces of my puzzle. I have figured out what X is. I have figured out what Y is. If you want to put them neatly and tidily in one specific spot in your question with a box or some sort of indication of what the correct answer is, that's a great strategy to make sure it's obvious. So again, process of elimination is a little more complex than the other two methods we've looked at, but it actually is probably the one you're going to use the most moving forward. So 3 levels of difficulty that we went through. First method, you didn't have to change anything about either of the equations. It was already set up with one of the variables, equal coefficient, opposite sign. Method 2, we had to change one of the equations such that we had the same coefficient on one of the variables. So change 1. And then third level of difficulty, we had to change both of the equations to achieve a situation where we had the same coefficient with an opposite symbol. And that does it for the method of elimination.